Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome viewers to our channel. Today we are going to look at transformation of waves. And as you know, waves undergo transformations. Examples of transformation of waves include stretch and translation. Now, if we consider the following diagrams, here we have two waves. We can call this one wave A and this one wave B. Now, these two waves, they have a relationship. If we look at the wave A, for A, it has an amplitude of 2, while wave B has an amplitude of 1. So if we want to fit wave B onto A, if we want to fit wave B onto wave A, we have to stretch the crest of wave B towards the crest of wave A. We have to stretch the crest of wave B towards wave A. And while stretching, the values on the x-axis are not changing. The values on the x-axis are not changing. So to describe that transformation, wave B fits onto wave A under a transformation of stretch, scale factor 2. How do you get the scale factor 2? Scale factor 2 can be gotten from the amplitude of A divided by the amplitude of B. Okay, the amplitude of A is 2 and the amplitude of B is 1. So 2 divided by 1, we are going to get 2. Good. Therefore, we say the value of x-axis are not changing. So we say x-axis invariant. X-axis invariant. By doing so, then we have described the transformation which maps wave B onto wave A. So here we also have two waves. Let's call this wave P, while this one wave Q. Okay, so for these two waves, P and Q, they have the same amplitude. They have the same amplitude, but wave Q is ahead of wave P angle, that angle theta. Or to fit wave B onto Q, then we have to translate wave P. We have to translate wave B. That means wave B has to be moved parallel to the x-axis, and not parallel to the y-axis. So in this case, when you translate P onto Q, then we say it goes under a transformation of translation. It undergoes a translation vector theta 0, where this theta is the angle difference between the two waves, and this 0, that means the value or the y-axis is constant. Conversely, we can translate Q onto P. Q onto P. That means we have to move Q backwards. We have to move Q backwards. So therefore, it will still be a translation, but since this time round the movement of Q is backwards, then the angle will be negative. The angle will be what? Will be negative. So that is how you are to tell the kind of transformation waves undergo. So in general, if you have the equation of the form I sine or cos of bx plus theta, then from this equation we can find the amplitude, we can find the period, we can also find the angle difference. The angle difference. And what is the angle difference? As I have told you earlier, wave P is ahead of P by an angle theta. So this angle theta is called angle difference. Now from this equation, how can we get the amplitude? So the amplitude will be equals to K. So the K stands for the amplitude. To get the period, then we say 360 degrees divided by B, where B is the coefficient of x. Where B is the coefficient of x, and the angle difference, will be equals to theta. Okay. For example, if we look the equation, y equals to 3 sine a half x plus 60. From here, amplitude will be equal to what? Equal to 3. That is the value of K. Period will be equal to 360 divided by the value of B, and the value of B here is a half. So divide by a half. This one means 360 times 2, which will be equals to 720. So the period of this kind of curve will be 720. What about the angle difference? The angle difference, so the angle difference will be equal to 60 degrees. So if we look example 2, y equals to 4 cos x minus 30. So from here, the amplitude is equals to 4, period will be equal to 360 divided by B, and the value of B, which is the coefficient of x, here is 1. So therefore the period will be 360 degrees, and the angle difference will be equals to 30 degrees. So that is how you can tell the amplitude, the period, and the angle difference if you are given the equation of the wave. Thank you very much and welcome to our channel.